Okay, in this little video, I want to work a problem that is similar to problem 2 on quiz number 3. And so in this problem, I've given you the instructions of I'm asking you to prepare a 2 kilogram aqueous solution of a 10% weight-to-weight acetic acid. And I'm asking you to use a stock solution of 40% acetic acid, and I give you a density of that in grams per mil. Now, the first thing that you're going to need to answer is what is the mass of acetic acid that is needed? And so we'll just kind of diagram this way. One, we have to look at what we have. We're going to have a 10% solution of acetic acid, and we need, that will be in 2 kilograms total mass of solution. Now, the way that you would approach this is, and I'm going to give you kind of a generic way if you don't know how to deal with the percent. And sometimes people get stuck here. So if you take your 10%, you need to convert that to a fraction. So you're going to divide by 100%. If you do that, you're going to get 0.1. Now, 0.1 will be the fraction then of the mass of this solution that is going to be your acetic acid. So it's 0.1 times 2 kilograms. And so we're going to get basically 0.2 kilograms. And if we convert that from kilograms into grams, we would multiply by 10 to the 3 grams over 1 kilogram. Our kilograms cancel, and we get 200 grams of acetic acid is what is necessary. So that's what we need from our stock solution. Now, our second part of this problem would be to figure out, well, how are we going to get that out of our stock solution? And so we have to approach the stock solution and try and basically make some conversions there. So basically, the way I approach this is to determine what is the gram per mil concentration of acetic acid in a 40% stock solution. Okay, so the way that we can do that is we'll start off just considering a 100-gram solution, or 100 grams of this solution. And if we start off with that, we take 100 grams. And basically, for 100 grams of solution, we use the similar thing that we have above. We took our 40% divided by 100%. Right, we're going to get basically times 0.4, and we would get 40 grams of acetic acid is in a 100 grams of the solution, the 40% solution. Now, what is the volume of 100 grams? So we'll just kind of come over here next to that. And how will we determine the volume? Well, this is where we're going to use the density. So if we take 100 grams of this 40% solution and we multiply times 1 mil over 1.047 grams, then you might say, well, where do you get that? Okay, remember, we've got our density up here. Now you'd say, well, wait a minute, but that's 1.047 grams per mil. Well, remember, we're going to use it as a conversion factor. We need the grams on the bottom. We basically take 100, we divide by this, and we're going to wind up with 95.511 mils of solution. That's what 100 grams. This would be the volume of 100 grams, and this is the mass of acetic acid in 100 grams. And so to get the concentration in grams per mil, we can see that we're going to take our 40 grams, we're going to divide by our volume, and we come up with a concentration of 0.4188 grams per milliliter. Now, if we take, then we can figure out, well, what volume of, and this was actually be like a part 3, what volume of the 40% solution would give you your needed mass up here. So what volume is that going to take? Well, we'll start with our mass, our 200 grams, and we're going to use this mass to volume ratio that we determined here. And so to convert this into volume, we're going to take our 1 mil is equivalent to 0.4188 grams. Grams are going to cancel. And if we do this calculation, 200 divided by 0.488, or I'm sorry, 4188, then we are going to get 477.555 milliliters on our calculator. And then we're going to want to convert that into grams. So how do we convert this back into mass? Well, we're going to use our density again, except here we can just multiply by our density, 1.047 grams per mil. And we would wind up with basically 500 mils of the 40% solution. Now, finally, we would need to then find our mass of H2O. So we know what mass, what volume we would measure out, and that would basically be mass of H2O. But now we would need to know what volume of H2O, and we're going to just go with mass. So like here, if we weighed out 500 grams of the 40% solution, we can then weigh out how much mass of H2O would we need. Well, we would start off with our 2 kilograms of solution. We're going to subtract the mass of we've got 500 grams. We're going to convert that to kilograms. And you basically 500 divided by 1,000 would be half a kilogram. And so we wind up with 1.5 kilograms of H2O. So if we did this in terms of mass, we would take 500 grams of the 40% solution, and we would add 1.5 kilograms H2O. If we had a density for H2O, we could convert that into volume, and then we could have used the volume. So the main reason we had to come to our kilograms of H2O was because we convert to grams of 40% solutions, because we then wanted to get the overall final mass or final solution in terms of mass, which is what we were given. If we were given a density of water, then we could have just gotten the volume from the previous part of the problem. So anyway, this would be our answer would be, you're going to combine these guys in this way.